That's class. In this video I want to show you how to use Desmos to make a scatter plot and then determine if there's a correlation in the data set. So what we have here is a data set. We've got to click here to open the data set. But we're going to click on this button right here that allows us to copy this to a clipboard. Right click and copy, or Control C to copy. And then you just come into Desmos, Control V, Command V if you have a Mac, and paste it in there. Okay, it'll replace the labels on the top with X1 and Y1 by default. So this is what our scatter plot looks like. All right, it's kind of no rhyme nor reason to where the values are. All right, then it gives us these choices. Now I want you to see they all have 160 to 200 on the y-axis, and they all have 160 to 200 on the x-axis. It's pretty close to that in Desmos, but you can adjust that right here if you need to. You just click there, and you can change these numbers as needed if you need to. Okay, also it will give you, if you get out of frame, it'll give you this little zoom fit icon that'll zoom around it. So there's the data set that I see. So of the choices of scatter plots, it's obviously not A, it's obviously not C because it's not very correlated. It looks to me most like B because it does kind of rise to the right in that first little bit rather than kind of being behind as you go up. So it just kind of goes to the right a little bit as we go up. So it's going to be choice B. And then once we have that, it wants to know, does there appear to be a correlation between the two? And no, there doesn't really seem to be, because as we go left to right, sometimes the x coordinates are low and have low y coordinates. Sometimes the x coordinates are low and have high y coordinates. Sometimes the x coordinates are medium and have low y coordinates. Sometimes they're medium, have high. Sometimes they're high x coordinates and have low y coordinates. There's just no rhyme or reason to this. But the other way we can check is just to do a correlation calculation. So that's CORR in Desmos, open a parentheses, come up here, look at the top labels here, it's X1 and Y1. So that's what I'm going to type down here in the parentheses, X, just type 1 and it makes it a subscript, comma, Y1. And there's my value, so 0.071. So the correlation is virtually 0. So there's no correlation here. All right, there's all the different choices. The one I see is no. There does not appear to be any kind of a pattern to the data that I'm looking at. So there is the answer, and that's what we're doing on that first one. All right, it doesn't actually ask for correlation on this one. All right, let's look at an example where it does ask us to compute the correlation. So same thing, we're going to copy this to our clipboard, Control C, and then we're going to open it up in Desmos. Right, here's the one I just used in Desmos. I'm going to just click X and close both of those out, and then just paste this in there. All right, so there's that. And then I want to come down here and do the same thing as I did before. CORR X1, comma, Y1. All right, and there is the correlation. This time it's a much bigger correlation that we're seeing here. So it's almost a perfect linear correlation except this one point that's out of place. All right, Desmos gave me the scatter plot so I can easily match it with A. All the other ones don't have that pattern that we see in the Desmos plot. And then it wants us to find that correlation coefficient this time. All right, so 3 decimal places, as it says, this is going to be 0.817. All right, and then the next part is it says, determine whether there is sufficient evidence to support the claim of linear correlation. Okay, so that's where this comes in. The critical values for correlation. So we have, if you count it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. So you click there, and it says n equals, there's 11. So these are it's a hypothesis test. These are the levels of significance for the hypothesis test. So at 0.05 at 11, we'd have to get a correlation value beyond 0.6. So an absolute value. So we are at 0.8. So we're above that. Sorry. And then if we wanted to test at the 0.01 level, we're above that as well. So there does appear to be a significant correlation between these. Okay, the smaller the sample size, the more significant, the further out our correlation has to be. But for our sample size, 0.817, what we got for our correlation, is much bigger than both of these. So we do have significant correlation. All right, so when our correlation is bigger than the ones in the table, there is sufficient evidence to support the claim of a linear correlation between the two variables. So that's what we're going to select there. All right, and then it's going to ask us about the reason why we do the scatter plot. Okay, so I could have just looked at that R and said, okay, there's a linear correlation compared to the values in the table that we saw. So it's bigger than those, so there's correlation. But if I didn't look at the scatter plot, I wouldn't have known that it's almost perfect, just this one outlier. And what that would suggest to me, if I was the one putting this data in, that would make me wonder, did I maybe make a mistake on that number that was like 13-ish, this number right here? Did I maybe type something in that maybe that wasn't supposed to be a 12, maybe it was only supposed to be like an 8 or something? That would make me reconsider and look at my data again. If there's just a single point in the middle of the data out of whack like that. A lot of times that'll be just an error putting in there. So that's the reason why we put the scatter plot in there. The scatter plot here shows a perfectly straight line pattern except for that single outlier. Alright, so there's how we would use the data set along with Desmos to get the value of R, and then to use that value of R to conduct a correlation test, which means comparing R against these critical values in that table.